Rebecca Kennedy.
I'm Deidra Papakostas. I'm Leanne Maduka, and today on 60 Seconds, we're going to be discussing the simple harmonic motion of a clock.
Simple harmonic motion is a type of periodic motion, meaning that it moves at equal intervals of time. Examples of periodic motion include a rocking chair, a bouncing ball, and a vibrating tuning fork. Simple harmonic motion can be described using sine or cosine functions. For example, in this project, a cosine function describing the simple harmonic motion of a clock is found.
Elements of nature have always provided humanity with references for measuring time. The earliest Egyptian calendar was based on the moon cycles, but later depended on the movement of a star that rose next to the sun every 365 days. With this, they devised a 365-day year. The earliest method of telling the time of day was the sundial. It is not known when the sundial was invented, but they were certainly used in ancient Egypt and ancient Iraq. Water clocks were among the earliest timekeepers that did not depend on the observation of celestial bodies. These were built containers with sloping slides that allowed water to drip at a nearly constant rate from a small hole near the bottom. Markings on the inside surfaces measured the passage of hours as the water level reached them. These were some of the earliest clocks ever made. A clock must consist of a constant or repetitive process or action to mark off equal increments of time and a means of keeping track of the increments of time and displaying the result. The mechanical clock was invented in the Middle Ages. Who made the first one and when is not known, but it was around the end of the 13th century. Early clocks were normally in churches, and they were very heavy because they were worked by weights. However, about 1450, the coiled spring was invented and it made possible portable clocks. The first watches were made in 1510. Early clocks were not very accurate, but in 1657, Kristen Hudgens introduced the pendulum. Clocks became far more accurate, though they were still set using sundials.
The points were found using the Logger Pro software. A video of an analog clock completing one full 60-second repetition was inserted into Logger Pro. Then, a tool was used to trace the same point on the second hand of the clock as it made its repetition. 1 point was recorded every second, which is the x value, and the distance the point was from the horizontal line going across from 3 to 9 is the y value.
After gathering the data of the second hand's position on the clock for an entire minute and plotting the points on a graph, a cosine function can be determined from these points. The x-axis for these data points represents time in seconds, and the y-axis represents the distance in millimeters from the second's hand to what would be termed as the sinusoidal line of the clock, the imaginary horizontal line from the 3 to the 9. For this reason, the data begins above the sinusoidal line at t equals 0, hits the sinusoidal line at t equals 15 and t equals 45, the 3 and 9 hands, hits the bottommost point at t equals 30, and then climbs back up to its topmost value at t equals 60, completing 1 full minute or 1 period. Firstly, by comparing these data points to the graph of a sine function and to that of a cosine function, one can recognize that the function that fits these data points will be a cosine function with no phase shift, since the data hits its topmost point at t equals 0 and then dips to its bottommost point until it climbs back up to its topmost point by the end of the period. Then, by taking the average of the y values for the two topmost points, which is 346, and the y value of the bottommost point, which is 242, the vertical shift for the sine function can be determined by finding the average of these two numbers, which is 294. Y equals 294 therefore refers to the sinusoidal line, the horizontal line halfway between the topmost and bottommost points, the horizontal line referring to the vertical shift. Based on the vertical shift of 294 up the y-axis, the amplitude can be determined by finding the difference between the topmost point in the sinusoidal line and the difference between the sinusoidal line and the bottommost point. 346 minus 294 equals 52, and 294 minus 242 equals 52. The amplitude is therefore 52, and the amplitude refers to how high the sine function reaches above the sinusoidal line and how low it dips below the sinusoidal line. Furthermore, since 1 period refers to 1 time around the clock, or 1 repeating motion, which on a clock would be 60 seconds. 1 period is therefore defined as being between t equals 60 and between t equals 0 and t equals 60, since the x-axis refers to seconds. To find b in the equation, one must simply set 2 pi over b equal to 60 and solve for b, which is pi over 30. The final equation then is f of x is equal to 52 cosine pi over 30x plus 294.